Dear third grade students, this is our second recorded lecture for the module entitled Computer Applications in Management and Economics. You know that I only teach the economic part using views. Recorded lectures are used instead of face-to-face interactive lectures. This is done as a precautionary approach to fight the spread of coronavirus. Praying for you all to be safe and healthy. The recorded lecture is to be used in conjunction with your textbook. I take into my consideration that recorded lectures are completely different from interactive ones, so I'm trying to speak slowly. Kindly don't hesitate to contact me for any further questions and help. The current presentation covers two main points. The first point is transformation of data. The second is generating new series from existing ones using views. With regard to the first point, we could say that in conducting empirical research, we often work with transformed variables rather than the original variables for which we collected the data. For example, we may collect data about nominal variables, but for the purpose of our research, we need to convert such variables into real variables. Thus, we briefly discuss the most commonly used transformations by economists. These transformations include inter alia converting nominal variables to real variables and taking the natural logarithm of original variables. Concerning to the second point, we could say that computers can do all the arithmetic calculations, so there is no need to convert data manually to fit our model. For instance, if the model under consideration calls for per capita real income, then we could collect information about the nominal income, a price index, and population. Finally, we let views perform the appropriate transformation to obtain per capita real income. As we have just said, in practice, we may need to work with transformed variables instead of the original variables. The precise nature of the required transformations depend on the topic under consideration. The most common transformations used by econometricians when dealing with time series data include converting nominal variables into real ones, using natural logarithms of original variables, differencing time series variables, and computing growth rates. You already know from macroeconomics that a nominal series incorporates a price component that can hide the essential features that we are interested in. To avoid this problem, we convert nominal series to real ones. This is done via employing proper price indexes. For instance, the consumer price index is used to convert nominal consumption expenditure to real consumption expenditure. For the nominal manufacturing production, we could use the producer price index to convert it to real production. Whereas, for gross domestic product, we use the GDP deflator. All these variables are converted to real ones through dividing the variable of interest by the appropriate price index. However, if we have a variable in a real form, converting it to a real variable is somewhat different. Generating the real variable in this case requires subtracting the change in the price index from the nominal variable. For instance, Real interest rates are computed as nominal interest rates minus the inflation rate. Converting economic and financial data series into logarithms is common in econometrics for many reasons. These reasons are discussed in pages 98 and 99 in your textbook, so kindly refer to them. When dependent and independent variables are converted into logarithms, the regression coefficients are interpreted as elasticities. For instance, assume that you are asked to estimate the demand elasticities for a certain product, say for example for KFC products. Then convert the time series data of quantity demanded, consumer income, and prices of related goods into logarithms. Once you do so and estimate the regression model, in this case, estimated coefficients are demand elasticities. Recall that in chapter 1, we said that economic and financial time series are likely to consist of up to 4 components. These components are trend, cyclic variations, seasonal variations, or irregular movements. A trend shows a smooth, general, and long-term tendency of the time series data to increase or decrease over time. In order to remove the trend component from a time series data, we need to employ differencing. By differencing, we mean computing changes between two successive periods. For example, equation 3.1 provides the first-order difference of variable y, whereas equation 3.2 gives the second difference of the same variable y. If we compute growth rates of two variables, it will be possible to explore how variations in these two variables are linked during the same period of time. There are two types of growth rates. These are discretely compounded growth rates and continuously compounded growth rates. The discretely compounded growth rates are computed according to equation 3.3. In continuously compounded growth rates, both the logarithmic and differencing transformations are used. The continuously compounded growth rates are calculated according to equation 3.4. Note that if you are asked to compute financial returns, you should use equation 3.4. I mean that this is very common when using financial data. In other words, if you are asked to compute stock market returns for the Egyptian stock market, you could use equation 3.4 to do so. Kindly note that, in addition to the transformations discussed in the previous slides, Table 3.1 in page 102 gives some useful transformations for generating new variables from existing ones. These new transformations include obtaining the absolute value of a variable and obtaining its square root. EVUs provides several ways to create new series from existing ones. To generate the new series, you can use Quick Menu from the main menu, the General button in the Workfile toolbar, or the command window. These three methods are to be briefly discussed in the next slides. To generate a new series from an existing one, click on the Quick menu from the main menu toolbar. By doing so, a drop-down menu appears. Select Generate Series as shown in the screenshot 3.2. When you select Generate Series, you will be introduced to Generate Series by Equation dialog box. This dialog box is depicted in the screenshot 3.2. To create the real GDP variable in eViews, we type equation 1 in the Generate Series by Equation dialog box. We then hit the OK button. Note that RGDP is the new variable to be generated from the two existing series, which are the nominal GDP and the price level. In order to create the economic growth variable in eViews, we type equation 2 in the Generate Series by Equation dialog box. This is followed by pushing the OK button. In this equation, EG is the new variable to be created from an existing variable, which is RGDP. Finally, in order to create the natural logarithm of narrow money supply variable in eViews, we type equation 3 in the Generate Series by Equation dialog box. Then we press the OK button. Note that LM1 is the new variable to be created from an existing variable, which is M1. The Generate button from the Work File toolbar could be used to generate a new variable from an existing one. By clicking on this Generate button, you will be introduced to the Generate Series by Equation dialog box. This dialog box is shown in the screenshot 3.2. We already have talked about this screenshot. Then you can type an equation to generate a variable of interest. Here we will create stock returns for the Egyptian stock market using data of the EGX30 index. To do so, we use the following equation, which is shown by the screenshot 3.11. In this equation, we have two variables, the new variable and the original one. EGX30 represents the weekly returns of the Egyptian stock market. It is the new variable which is generated from the original values of the index itself. The command window could be used to create new variables from existing ones. When you type the required formula, hit the Enter key. We now use the command window to generate a new variable called vol to measure the weekly volatility of the Egyptian stock market. Absolute returns could be used to indicate the volatility of an exchange. We could use two different codes to obtain the same variable. You can either use the first code or the second code. After typing the required code, kindly press the enter key. In these two formulas or codes, vol is the new variable to be generated, whereas EJX30 is the original variable of interest. Finally, at abs is the function used to compute the absolute value of a variable. Typing errors and error messages in eViews. Given that we are humans, we are likely to write some errors when typing codes required to create new series from existing ones. If you type a wrong code, eViews informs you via an error message. Your textbook identifies two common errors when writing codes to generate variables. A relevant question might be, what are these common errors? Another relevant question is, what are the eViews error messages in these two cases? Answer these questions on your own. This is the end of our presentation. Thank you so much.